Hello guys, welcome back to the channel. Welcome back to Math Plus Tech. In today's video, I'm going to be talking to you about the domain of functions. We'll consider the domain of single variable functions first. Obviously, that's the easiest. And then we'll consider the domain of multiple variable functions, so that we kind of link the basic to the a little bit more advanced version of the functions. Yeah. Alright, now let's consider the domain of single variable functions. Now, what is domain? Domain is basically the set, it's a set of all the allowable values, of the independent variable of a function. So if I have a function f defined on x to be, let's say, s squared, when I talk of the domain, I'm talking of all the values of x that this function is defined for. So considering just f of s is equal to x squared, we could say that this function is defined for all real numbers, because for every real number I substitute in terms of x, I would have a value for the function. So for this particular function, this function is defined for all real numbers, the set of all real numbers. So essentially, we have two factors that can influence the domain. Factor number one is the expression of the function. Factor number two is the nature of the function. I would go on to explain what I mean by saying the expression of the function, the nature of the function. When I talk of the expression of the function, I'm basically referring to the algebraic expression that is used to calculate the functional value. So the above example that we considered, f of x to be equal to s squared, I am basically referring to s squared. Now, sometimes the nature of this expression kind of restricts us from choosing certain values for the input variable. For example, if I have g of x to be equal to 1 over x, this function is defined for all real numbers except when x is equal to 0. Obviously, we can't divide by 0. So in order to avoid the division by 0, we remove that from the set of all the real numbers. And that new set that we get after removing 0 from the set of all real numbers becomes the domain of this particular function, g of x. Now, the second thing that I was referring to, the nature of the function. And what I mean by the nature of the function is basically the nature of the natural phenomenon or the natural thing that we are trying to represent or model with a function. For example, if I have a function, let's say a, which takes an input x, asks the length of, let's say, a square, and calculates the area. So this would probably be x squared. Yeah, it takes the length of the square and then returns the square of that length, which is the area of the square. Yes, it's the same function as I wrote here. F of x is equal to s squared, and it's the same thing I written by a of x is equal to x squared. But the fact is that we have stated that the x over here is referring to the length of the side of a square, and that cannot be negative. And for that matter, it gives the restriction on the domain to become only positive values. So we'll be having the domain, the set from which we can take the length as the set of all real numbers for which s is greater than 0. Again, this is a very basic concept that will not go much into detail of, because that is not what the scope of this playlist is going to be about, this series is going to be about. But to make things clearer, let's take another example again. Let's take a function h of y to be equal to 2y over y plus 3. Considering real numbers, we want to avoid division by 0. So what we do is that we make sure that this denominator is never equal to 0. And the only way that this denominator y plus 3 will be equal to 0 is if y is equal to negative 3. And as such, the domain of this function becomes the set of all real numbers. Remember, it's a set of all real numbers. So to be a set of, let's say, y, such that y is a member of all real numbers, except that y is equal to negative 3. And this set becomes the domain of this particular function, just because we want to avoid division by 0, since we are considering the real number system, the real numbers. Alright, now that we have understood what it means to talk about domain, and we've looked at the domain of single variable functions, let's now move on and look at the multivariable functions. Let's look at the domain of multivariable functions. Again, it's the same concept as the single variable functions. If I have a function, let's say capital G, defined on a and b as a squared plus b squared all over a plus b. Obviously, we know that this function is a rational function, and of course, we don't expect the denominator over here to be equal to 0. So we want this not to be equal to 0. And the only way that this denominator a plus b would be equal to 0 is if a is equal to negative of b. And as such, we know that for every other real number, this expression will be valid. There will be value for this g, such we can conclude that the domain of g is given by the sets of x and y, x comma y, where obviously to be a set of points because it depends on two values, so the input would be points, to be the set of all points x, y, such that s and y are members of the real number set, and or except, and a is not equal to minus b, or except a is equal to minus b, anyhow you want to put it. And this set now becomes the domain for this particular function g of a comma b, which is equal to a squared plus b squared all over a plus b. Now let's consider another function of multiple variables. Let's say a function capital F defined on x and y, where x and y are the length and the width of a rectangle. So we want this function to return the area. So if it takes the length and the width, we expect to multiply those two, and that would be equal to the area of rectangle of length x and width y. Now obviously for the real number system, this as an expression xy is possible for all the real numbers, but because we want this function to output the area of a rectangle of side x and y, the length of side x and y, we would want those lengths to be greater than 0. As such, we are kind of reducing our domain, the set of all allowable values of x and y. We are reducing that set by enforcing the rule that the length of the sides should be greater than 0. So the domain of this function would then become the set of all points x comma y, such that s and y are members of the real number set, but or except, but x should be greater than 0 and y2 should be greater than 0. Given that x is greater than 0 and y is greater than 0, we would have a length of the rectangle. Obviously the length cannot be negative, and then the width too cannot be negative. So we want to impose this part onto this real number set, so that we'll get our new set that would be the domain, and then this would be the set of all the allowable points that would provide a value that would satisfy this function f, which returns the area of the rectangle of length x and width y. And yeah, that's it for this particular video. I thank you all for watching. You should go and revise more on this, try more examples, try finding the domain of several functions, and then these functions should be of single variables, multiple variables, even 3 and 4 variables. It could be a function g that finds the volume of a cuboid of sides x, y, and z. So essentially this will be equal to x, y, and z. So you could find the domain of these functions and all of that. Thank you all for watching this video. If you enjoyed the video, please leave a like behind. Subscribe if you are new around here, and I'll see you in the next one.